Structures. My name is Professor Seaman. First name is Jeff, and I am teaching this course. This is an online course. What I will not do is I'll make it as interactive as possible each week. There is 8 weeks for this course. This first week is just kind of a lot of getting set up, and maybe you've already taken classes and you are set up. So each week I will have a interactive session on the lecture as if you were in class, so you can watch it at your own time. So each week I will do a lecture and kind of go over kind of what it's about for the week, and then I may have some videos on walkthrough his lab, but for the most part, this will kind of give you a good understanding. You can read the book, you can ask me questions. I'll send out information on Slack. I'll set up a different video on that. And what I'm interested in is you guys getting involved with Slack. So once I set up a channel for everyone, I'll do a demo on that. And also another thing within this first week is I'll be interested in, we'll do a discussion, introduction, and it'll be a video introduction. So since we're online, everybody could kind of place a photo to the person behind the screen, I guess. So this class is data structures, and we'll just get started. Chapter 1. So, and this is kind of a interesting topic. We're going to talk about phone book, and I would hope that everyone knows what a phone book is. I only say that because I don't even see a phone book anymore in this day and age, because it's a topic that is old. Verizon, Bell Atlantic, whoever they were in the past used to display these. Everyone used to get these phone books, and that's how you looked up people's names and so forth. So when you think about a phone book, suppose you have a phone book that has like 320,000 names. So let's say that you live in Chicago and you have all these names and you need to look up someone's last name. Assume that all the names that you're looking up are unique. So let's say Smith, for example, common last name that has thousands of Smiths in Chicago. Assume they're in no particular order. So let's pretend the Smiths are all over the place. They're not in your chronological order. Maybe they're based off of region of the city. So you have different parts of the city. Maybe there's the north side, the south side. They're all in that type of breakdown. How long does it take to find that person in a phone book if you don't know what area that they live in? And then I ask a question, who knows what a phone book is? So suppose all the entries in the phone books are sorted. How long does it take you to find a name in a book? Well, it probably takes equivalent amount of time. Because when you're looking for this, and this used to be the common way, now we have everything at our fingertips. We type something in, boom, we have answers in 2 seconds. That's the environment we live in. So a way to organize the data, preferably efficiently. An array, we can use an array to store the names in a phone book. We can use a linear search to find a name. So an array allows us to store values in a bracket. Well, it is a bracket, but it allows us to display it in a bracket. A sorted array to store names in a phone book. So kind of going back real quick with a linear search, it would be like, if you're doing linear, it'd be like a sequential search and a method for finding an element within a list. So let's say that you had a good example is, let's say that you had 5 people standing in a line. They're all waiting to get into, okay, when you go over stage AE, there's all these people standing in line to get into a concert. And you have all these people, we'll just say 5 people. So it's the beginning, it's 8 o'clock in the morning, concert doesn't start till 8 p.m. at night. A linear search has 5 people, and it goes from A to B to C to D, and it just keeps going over until it's able to find what it needs to find. So, it's a method for finding the element in the list. So let's say that It's looking for someone who's wearing a number 5 jersey or someone wearing a number 3. It's able to go, okay, what's the first? It looks at the first person and says, what are you wearing? Oh, okay, I'm wearing number 7. So then it goes to the next person and so forth until it finds that person. We have a sort array to store names in a phone book. So sort it allows us to use the binary search to find a name. It allows us to identify what we're looking for specifically. A dictionary, key value pairs. I put SOR to sort names in a phone book, so that's my mess up. Use a hashing to find a name. So hashing is kind of a way to save data in a temporary location, and it allows you to utilize that data later on. So think about way back in the day when video games didn't have disk drives, and they had to use, they had some type of memory, but not like we have today. And that could have been something that they had utilized. 2 important questions: how much time is necessary, and how much space is necessary? Those are very common questions. Time: how long is it going to take? Space: how much space are you going to use when you do this? Common stuff. So let's say we double the number of names in the phone book. Now we have over 600K. How much longer do I have to search? Answer is perhaps surprising. Linear search, twice as many steps on average. And think about that. Let's say that you're back at stage AE and you have people wrapped around a corner and there's maybe 500 people waiting to get into the concert, right? And you have to search each person. It's like if you physically had to walk up to each person and maybe ask them a question, it would take you a number of hours. If you have the binary search, it's only using one additional step. So the binary search is quicker, and then hashing has no additional steps. So you want to go with the quickest route versus kind of putzing around. That's what's important. All right, motivation. Why do we have to know about data structures? Well, Git actually has a simple design with stable and reasonably well-documented data structures. In fact, I'm a huge proponent of designing your code around the data rather than the other way around. And I think it's one of the reasons Git has been fairly successful. I will in fact claim that the difference between a bad programmer and a good one is whether he or she considers his or her code on his or her data structures more important. Now I added the her in there because I forgot to throw it in there. Bad programmers or developers worry about the code. Good programmers worry about data structures and the relationships. And that was not said by me or Professor Vortman, but that was said by Linus Torvalds. So, and that's the case. If you set up a good data structure and you know it can't break, then any program will work with it. Oops. All right. So what is Git? At this point, I figure we know, and this will be something that you guys will be responsible for setting up. Git is a version control system. It's a way to push source code out into Git. It's a way to store it. There's GitHub, which is a web-based access environment, which the two communicate with. Git itself is a version control, allows you to store it locally, but GitHub, think of that being the cloud where you push your code up to. Slack is a communication software for developers and others. It also, integrates with GitHub, and we will use this in this class. If you need to get a hold of me, Slack me. All right, so what will we cover in these chapters? Well, at this stage in the game, you're going to have a review of CIG 160, which is JavaScript review. Arrays, stacks, talk about queues, linked lists, sets, dictionaries and hashes, trees, graphs, sorting and searching, patterns of algorithms, and algorithm complexity. A lot of stuff to cover. Create a GitHub each week I want you to have, so you'll create your Git repository out in GitHub, and then you'll have modules, say module 1, and then the name of the assignment, whatever it is. So say trees, so it'll be module 1 trees, module 2 this, module 3, so forth. You have to do that. And this right here is letting you know that use Atom. You use something else if you want, but all my videos will be based off of Atom. Setting up your environment, go out here and set up your environment, and FileZilla as well is a good thing to download. All right, so JavaScript's everywhere. What is JavaScript? It's an internet language. It's a script that lives out on the internet. It's a script that lives in every browser. If you have it, it'll do some fancy stuff. Node.js is a JavaScript server side. So what you could do is it acts as a web host environment. MongoDB is a JavaScript database. That'll be something that I'll be teaching in the fall, is a NoSQL class using MongoDB. And then Apache Cordova and React Native. Those two are both used for mobile app development. React Native also is used for desktop applications. Apache Cordova is a way to write code in JavaScript and HTML and push it out to multiple platforms, one being Android and one being iOS. But there's some issues with that process. Survive the course. Well, you learn programming by doing it. Spend some time almost every day. Start early. Read the chapters before class. We'll read the chapters, in general for the week. Use the developer tools. Keep your code working. Fix any errors immediately. And any questions is how to ask questions, or Slack me. So topics, setting up environment, JavaScript basics, control structures, functions, object-oriented, debugging and tools, and then ECMA scripts. All right, so that's chapter 1 right there. I'd like to send any questions, but at this point there isn't. All right, topics. Why should we use arrays? Creating and initializing arrays, adding elements, removing them, adding and removing elements from a specific position, two-dimensional and multi-dimensional arrays, and in reference to JavaScript. So arrays store data sequentially, provides an efficient way to find elements. Element can be added, inserted, or removed. Possibly multi-dimensional arrays, and what that means is you have multiple brackets. Bracket here, bracket there. Use the loops frequently. Constructors, an array or a preferred, this guy here. Methods could be an argument, maybe IDX is for number, comma, push means you push it to the new element. Unshift is the way that you position stuff. And splice with the number and a count. You're doing like a loop here, and more or less is kind of added stuff in between stuff. And here's an example of stuff that you can look at. So you have your constructors, which is var variable ARR equals, and it has the information in brackets. That's the preferred method. Or you could do it this way. You could do new stack like this, or other data type. Access loop. So if you want to access your environment, you could do ARR 13. So whatever value is in 13, it will grab, starts with 0, and once it gets down to 12, which will be 13, it will grab whatever value is there, depending on if you have a single array right here. So this is a single dimensional, but if you had a multiple one, you'd have comma another bracket, so each one would store a certain amount of data. This one right here says variable temp equals 13, and then you do var r temp, which is associates with number 13. You could just do var without doing that way, and retrieves whatever that value is that's in that 13 position. This way right here is a different way of doing it, and here's your loop. So that was a pretty quick one there. Any questions? Well, I will not know if you have any questions. It's 11:54. I am exhausted. I've worked all day, and I'm making this video now, so that's usually how things work. I'll wait till late. All right, so that's it for this week on the lecture. Look for another video on how to use Slack. Look for a video on the week 1 discussion, which will be involved with us doing a introduction of ourselves. I'll save that for tomorrow when I'm not super tired. So thanks for watching. Welcome to week 1, and hope you guys have a good week. Talk to you soon.